Look up. The sky is blue. You know this the way you know your own name. It is the first color a child reaches for in a box of crayons when they want to draw the world above their head. Now walk backwards. 30,000 years. Past the cities, past the farms, past the last ice. Find a man standing at the mouth of a cave in the cold morning, looking up at exactly the same sky, lit by exactly the same sun, through exactly the same eyes you were born with. He sees it. The light hits his retina. The signal runs down his optic nerve. His brain builds the picture. And in his entire language, there is no word for what he is looking at. Not a rare word, not a poetic word, nothing. The sky above his head is enormous, and it is everywhere, and it has no name. This is not a story about bad eyesight. His eyes are your eyes. Same cones, same rods, same wiring. If you swapped his newborn son with yours, that child would grow up reading street signs and picking out shades of paint like anybody else. This is a story about something stranger. It is about the possibility that a color can exist in the world for 100,000 years before anybody bothers to invent it. And it starts, of all places, with a British Prime Minister who could not sleep. His name was William Gladstone, 4 times Prime Minister of Britain. A man who ran an empire during the day and read ancient Greek at night. In 1858, he published a book about Homer. Most of it is exactly as dull as it sounds, but buried in the middle is a chapter that made people genuinely uncomfortable, and it has never really stopped. Gladstone had done something nobody thought to do. He had counted. He went through the Iliad and the Odyssey and tallied every color word Homer used. Tens of thousands of lines. Warriors, ships, blood, bronze, wine, field, sea, sky. And what came back was wrong. Homer calls the sea wine dark, not blue, wine dark. He uses the same word for the sea that he uses for a bowl of red wine, and he uses it over and over as if it is the obvious description. He calls sheep violet. He calls iron violet. He describes honey as green. He calls the faces of frightened men green. He calls the sky bronze, iron, starry, great. But the sky in Homer is never blue. Black appears about 170 times. White about 100. Red, maybe 13. Yellow and green, under 10 each. Blue, 0. 2 enormous poems. The sea in almost every scene. The sky over every battle. And not one blue thing in either of them. Gladstone's conclusion was blunt and wrong, and it took a century to clean up. He decided the Greeks were partially colorblind, that the human eye had improved since Homer's day. That evolution had handed us better hardware in 3,000 years. It is a bad answer, but it was a very good question, and other people went looking. A German philologist named Lazarus Geiger picked it up next, and he widened the net. He read the Vedic hymns of India. Thousands of lines about the heavens, the dawn, the sun. Endless devotion to the sky. No blue. He read the Icelandic sagas. No blue. Early Chinese texts. No blue. The Hebrew Bible. No blue. The Quran. No blue. Different continents. Different centuries. Languages with no contact with each other that could not have copied each other's blind spot. And they all had the same hole in exactly the same place. Then Geiger noticed the part that turns this from a curiosity into a pattern. The colors do not go missing at random. They go missing in an order. Every one of these languages had words for black and white. Every single one. After that, the next word to appear was almost always red. After red came yellow, or green. Then, last at the very end, blue. A century later, 2 Berkeley researchers, Brent Berlin and Paul Kay, put a real number on it. In 1969, they compared basic color terms across 98 languages from every inhabited continent, including languages spoken by a few hundred people in places with no writing at all. The order held. Stage 1. Every language. Dark and light. Black and white. Cool and warm. Stage 2. Red, always red. Nothing else ever gets there first. Stage 3, green or yellow. Stage 4, the other one of that pair. Stage 5, blue. Only after blue do you get brown. Then pink, orange, purple, gray, in whatever order a culture happens to want them. Languages skip forward at different speeds. Some stopped at 3 terms and stayed there. But almost nobody breaks the sequence. You do not find a language with a word for blue and no word for red. That combination essentially does not exist. So the question stops being about Homer's eyes and becomes something much better. Why does red always win, and why does blue always lose? Start with red, because red is easy. Red is blood. Your own, leaving your body, which is the single most urgent piece of information a human being can receive. Red is a wound on a child. Red is the flush of fever on a face. Red is meat, and whether that meat is fresh or spoiled. Red is ripe fruit hanging in green leaves, which is very likely why our primate ancestors evolved 3-color vision in the first place, tuned to pull red berries out of a wall of foliage. Red is fire. Red is ochre, the iron-rich earth that humans have been digging up, grinding and smearing on themselves for at least 300,000 years. Every one of those things changes what you do next. A word for red is a tool. It saves lives, finds food, marks the dead, decorates the living. Of course it comes first. Now try to do the same for blue and watch it fall apart. Point at something blue in the natural world. Go ahead. The sky, which is not an object. You cannot pick it up, carry it, trade it, or hold it against something else to compare. It changes all day. It is white at noon in some places, gray for a week at a time in others, black for half of every day. It is the least reliable thing you could possibly name a color after. Water. Also, not blue. Scoop it up and it is clear. The sea is gray, brown, green, black, or whatever the sky is doing to it. Wine dark some days if you have ever actually watched the Mediterranean at dusk. Blue eyes, which contain no blue pigment whatsoever. The color comes from light scattering inside the iris, the same physics that colors the sky. Blue feathers. Same trick. There is no blue pigment in a jay's wing. Crush the feather and the blue dies. It is structure, not substance. Blue flowers exist, and they are rare, and most of them are small, and almost none of them are edible or dangerous or useful. And here is the part that really settles it. In the entire natural world available to a person living 50,000 years ago, there is essentially no blue pigment. Nothing you can dig up, grind down, and rub onto a surface to make a blue mark. You can make black from charcoal on any night of your life. You can make white from chalk and ash and ground bone. You can make red and yellow and brown from ochre, which is lying around on the ground on 4 continents. You cannot make blue. Not from anything nearby. Not for 100,000 years. So there is nothing to point at, nothing to trade, nothing to make, and nothing that will kill you. The word has no job. And words that have no job do not survive. Which brings us to the objection you have probably been building this whole time. Fine, they had no word. But surely they still saw it. Surely a caveman staring at a summer sky and a bowl of blood knew perfectly well those were 2 different things. Yes. Almost certainly yes. The eye is not the issue. Human color vision has not meaningfully changed in the time we are talking about. The genes for the 3 cone types are old, shared, and stable. A person from 40,000 years ago had the same photoreceptors you are using to read this. So the question sharpens one more time. If they could see it and we can see it, does the missing word actually change anything at all? And this is where somebody finally ran the experiment. In northern Namibia, there is a people called the Himba. They are cattle herders, and their color language is genuinely different from yours. They have a term, Zuzu, that covers dark blue, dark green, dark red, black and purple. One word for all of it. They have another vapa for white and some yellows, another baru that takes in certain greens and blues together, another dambu for other greens, reds and browns. Their categories cut the spectrum in places yours does not cut it. And they cut through the middle of a boundary you treat as obvious, because for them, blue and green are not separate countries. Researchers ran a simple test. Show someone a ring of colored squares, all the same shade except one. Find the odd one. When they showed Himba speakers a ring of green squares with one square a slightly different green, they picked it out fast. A shade of green that Western observers stared at and shrugged at and guessed on, because to us those squares were the same color. Then they reversed it. A ring of green squares with one blue square dropped in. To you, that would take about half a second. It jumps out. Himba speakers slowed down. Some got it wrong. Because their language files that blue inside the same category as those greens, and their attention had never been trained to treat the boundary as a boundary. Nobody's eyes were broken. Both groups were looking at the same photons. What differed was which differences their language had spent a lifetime telling them to care about. And you do not need to fly to Namibia to find this effect. It is running inside Europe right now. Russian does not have one word for blue. It has two, and they are not shades. They are separate basic colors the way pink and red are separate to you. Goluboy is light blue. Sinai is dark blue. A Russian child learns them as two different things, not as one thing with a dimmer switch. Researchers put Russian and English speakers in front of a screen and asked them to spot which of two blue squares matched a third. When the two squares fell on opposite sides of the Goluboy-Sini line, Russian speakers were measurably faster than English speakers. Not by a lot, by about 1/10 of a second, consistently. And when the researchers loaded the participants down with a verbal task at the same time, something that jams up the language part of the brain, the Russian advantage vanished. The eyes were doing the same work in both groups. The extra speed was coming from the word. Then look at Japanese, where the boundary sits somewhere else entirely. Ao is an old, deep word that historically covered blue and green together. Midori, the word for green, is comparatively young as an independent basic color. And the residue of that older map is still visible in the modern country. Japanese traffic lights are legally described as AO. The go signal is called blue. For decades, the government's answer to this awkwardness was not to change the word, but to change the lamps, pushing the green towards the bluest green that still passes international standards. A nation adjusted its infrastructure to fit its vocabulary. Green apples are AO. A young, inexperienced person is AO. The word did not shrink neatly when Midori arrived. It left fingerprints all over the language, and every one of them is a place where the drawers used to be arranged differently. Now watch a 2-year-old, and you will see the whole process compressed into about a year of somebody's life. Color words are strange to learn. Children pick up hundreds of nouns quickly. Dog, cup, shoe, nose. They point, you name it, it sticks. Color does not work like that. Toddlers will happily use color words for months while getting them completely wrong, calling a red ball green, calling grass blue, cheerfully and confidently. Parents assume something is broken. Nothing is broken. The problem is that color is not a thing. It is a property, and a slippery one. A shoe is a shoe from any angle. But a shirt in the sun and the same shirt in a doorway are throwing wildly different light at the eye, and the child has to learn that those are the same color. While a blue shirt and a blue sky, which have almost nothing else in common, share a name. They are being handed a set of invisible boundaries drawn by people who died centuries ago, and told to find them. Every human being who has ever spoken a color word had to do that work. You did it. You just do not remember. Now, honesty, because this topic attracts nonsense. You will find the claim, repeated confidently online, that ancient people literally could not see blue. That is not what any of this shows, and Gladstone's version of it was wrong when he wrote it. There are also real objections. Some scholars argue Homer's color words were about brightness, texture, and movement rather than hue, that wine dark is describing something closer to darkness and glitter than to redness. Ancient Egyptian, unusually, did have a distinct word for blue, thousands of years before it appears elsewhere. And Egypt is also exactly where blue was being manufactured, which fits the pattern rather than breaking it. The sequence Berlin and Cave found has been challenged, refined, and softened at the edges since 1969. It is a strong tendency, not a law. But the core has held up for 50 years, across hundreds of languages. Blue arrives late, almost everywhere, and it arrives late for a reason you can hold in your hand. There was nothing to hold. That is what a color word actually does. It does not create the color. It creates the category. It cuts a continuous, seamless spectrum into named boxes, and then it trains your attention to notice the walls between the boxes and ignore the variation inside them. Language does not paint the world. It hands you a set of drawers, and after enough years, you stop seeing anything that does not fit in a drawer. So the man at the cave mouth saw the sky perfectly well. He simply had no reason to file it separately from the dark of the sea, and the dark of a shadow and the dark of a wet stone. It was not a color to him. It was a condition of the world, like wind. Meanwhile, look at what he was obsessed with instead. Red ochre turns up at human sites for 300,000 years. It is one of the oldest continuous human behaviors we know of, older than our species in its modern form. There is a site in South Africa called Blombos Cave, 100,000 years old. Inside, archaeologists found a workshop, abalone shells used as containers, grinding stones, bone stirrers, charcoal crushed seal bone, and ochre mixed into a paste and left to dry in the shell. A paint factory, 100,000 years old, and every single thing coming out of it is red. They painted their bodies with it. They painted their dead with it. Burials from Europe to Australia come up stained with ochre, sometimes so heavily that the soil around the skeleton is still red when you open it. For 300,000 years, humans were pouring effort into color. Just never that one. And then, about 5,000 years ago, something remarkable happens. Somebody decides to go and get blue anyway. In Egypt, they invented it. Egyptian blue is the first synthetic pigment in human history. You take sand, a copper compound, lime, and a flux, and you heat the mixture to somewhere around 900 degrees, and you hold it there. Get it wrong, and you get glass, or slag, or nothing. Get it right, and you pull out a crystal that is a color nobody had ever been able to hold before. Think about what that requires. High-temperature furnaces, ground minerals, a repeatable recipe with a narrow tolerance. Somebody had to want blue badly enough to spend generations learning to manufacture it, because the planet flatly refused to hand it over. That is the moment blue enters human material culture. Not found. Made. And then, having invented it, we lost it. Egyptian blue was made for something like 3,000 years, spread across the Mediterranean, coated the walls of Pompeii, and then the recipe simply stopped. By the fall of the Roman world, the knowledge was gone. Nobody wrote it down in a form that survived. The workshops closed, and for roughly 1,500 years, the first color humans ever manufactured was a lost technology. It was reverse engineered in the 1800s by chemists picking apart Roman wall paintings. And it turned out to have a property nobody expected. Egyptian blue glows in infrared. Shine the right light on it, and it throws back radiation your eye cannot see, brightly and unmistakably, for thousands of years after it was applied. Conservators now use this to find paint that has otherwise vanished. Statues that look like bare white marble, the ones that taught everybody the wrong lesson about how restrained classical taste was, light up under infrared cameras showing where the blue used to sit. Patterns on a robe, a band on a crown. invisible to us for 2 millennia, still screaming in a wavelength we do not have receptors for. There is something almost too neat about that. The color humans could not see a use for, that they had to build a furnace to obtain, spent the last 15 centuries signaling in a part of the spectrum we were never equipped to notice. The other route was to go and dig it out of a mountain. Lapis lazuli, a deep blue stone, comes from a handful of mines in the mountains of Afghanistan. For most of history, essentially one valley supplied the entire world. Ground into powder, it becomes ultramarine. The name means beyond the sea, because that is where it came from as far as anyone in Europe knew. It was, weight for weight, more expensive than gold. Renaissance contracts specified how much ultramarine a painter was allowed to use and who was paying for it. That is why the Virgin Mary wears blue in so many paintings. Not theology. Budget. The most expensive pigment went on the most important figure, and after enough centuries, the accounting hardened into a symbol. Blue was a luxury good for 4,000 years. Now count the blue within 3 meters of you. Screens, denim, logos, toothpaste, road signs, packaging. Blue is the most common favorite color on Earth, reported by roughly a third of people in survey after survey across country after country. It is the safe color, the corporate color, the calm color. The color with no word became the color everybody picks. That took about 5,000 years, which sounds like a long time until you set it against the 300,000 years we spent grinding red rocks. So go back to that man at the cave mouth one last time. He is not primitive. He is not colorblind. He is not missing a piece of his brain. He is a fully modern human being with your eyes, your retina, your visual cortex, standing under a sky that is pouring the same wavelengths into his head that it pours into yours. The only thing he does not have is the drawer to put it in. And the reason that should land is this. Somewhere between him and you, people made that drawer. Not one person, not on purpose. Thousands of small decisions across thousands of years about what mattered enough to be worth a sound. Somebody smelted the first blue. Somebody carried the first lapis over a mountain. Somebody's grandmother used a new word for the sky and it stuck. Color words are not something you were born with. They are something you inherited. They are a technology, invented in pieces, handed down, and installed in your head so early that it feels like eyesight. Every time you look up and think that word without trying, you are running a piece of software that is younger than farming. The sky did not change. We did.